Hello students. Today in this class we will discuss about few basic concepts of conservation of momentum and some concepts of impulse. Then students, in conservation of momentum, whenever we talk about the term conservation, then we say that the thing can neither be created nor be destroyed, just like for conservation of mass, conservation of energy. Then similarly, just like this conservation of momentum is also there. And suppose, if you all know very well about the momentum is neural p, which is equal to the product of mass and velocity. Its SI unit is kg meter second inverse, or you can say kg meter per second. Kg meter per second. One more term we also know very well, force. F is equal to ma. Force is equal to mass into acceleration. And you can also write F is equal to m. At the place of A, we can write dv by dt. Change in velocity upon time is the acceleration. And again you can write F is equal to d mv by dt, where this v is a vector quantity. V is a vector quantity, that's why we call that the momentum is also vector and force is also vector. Then here you can see that F is equal to dmv, where m into v is the momentum. You can write dp by dt, which we have also discussed in the second law of motion. Let us talk about the conservation of momentum. Students, suppose there is a system of so many particles. Suppose there is a system of so many particles. There is no definite number, there will be so many particles are there. And these particles are experiencing so many type of forces. These forces may be internal forces, these forces may be external forces. Then suppose these particles are experiencing forces, and we all know, or we should know, that whenever there is an internal force over the bodies, when the atoms and molecular few bodies are attracting each other, then internal force always cancels out each other. Then just like, suppose you have this pen, the molecule of this pen are attracting each other with intermolecular force, but you can see there is no motion of this pen, because these internal forces are cancelling out each other. That's why we say that the internal forces is equal to the zero. Sum of internal forces is equal to the zero. And now suppose that each particle is experiencing a force, some forces. Suppose this particle 1 is experiencing a force F1, this F2, someone is F3, and so on. Then we can say the net force on this particle F is equal to sum of all the forces F1 plus F2 plus F3 plus F4, like this. Similarly, each and every particle has its own momentum. Each and every particle has its own momentum. And you can see the sum of all the momentums P is equal to P1 plus P2 plus P3 plus dot 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 and so on, Pi. Then we say that the net momentum will be equal to the sum of momentum of all the particles. Now let us differentiate this equation. What you will get, dp by dt is equal to the dp1 by dt plus dp2 by dt plus dp3 by dt and so on. And what you will get, dp1 by dt means force experienced by the first particle, because the rate of change of momentum is equal to the force applied according to the second law of motion. This will be the F1, this will be the F2, this will be the F3 and so on. And students, these all the forces are the external forces, because we have discussed that the sum of all the internal forces is equal to the 0. And now what happens, this is called F external. And if this F external is, if this F external is 0, then what you will get, the result will be dp by dt is equal to 0. Means dp by dt is equal to the sum of all the momentums, or you can say p is the equal to the sum of all the momentums, and dp by dp is the differentiation of this equation. And on differentiating these equations, we are getting that these all are combining together, and the result is the net force, net external force. And we say if f external is 0, then this dp by dt will be equal to the 0. And students, you all know very well, if differentiation of something is 0, if differentiation of something is 0, then that quantity is called constant. It means this p is the net, the total momentum of this system is constant. Means the momentum is not changing. Which type of momentum? The total momentum. Momentum of individual particles are changing, but the sum of all these momentum is always constant. It will neither increase nor decrease. That's why this is called the conservation of momentum. Then we say, in absence of any external force, the momentum of the system or the combination of a system is always remain conserved, and we write initial momentum is equal to the final momentum. And here you can see the P net is equal to conserve. That's why we say Pi is equal to the Pf. Initial momentum is equal to the final momentum. You can take an example. We can take an example to verify this, and the example is the recoil of a gun. Suppose you are going to fire a gun. Suppose you are going to fire the gun. Then, before firing the gun, students, suppose the mass of this gun is mg and the mass of this bullet is mb. B for bullet, G for gun. Suppose before the firing the gun, what is the initial velocity of the gun? 0, because gun is at the rest. What is the initial velocity of the bullet? It will be also 0, because bullet is also in the state of rest. Now suppose if you fire the gun, what happens? You will get a recoil. Gun will recoil in backward direction and bullet will start to move in the forward direction. Then what happens? Then the mass is still the mg and mb. There is no change in the mass, but now there is a new velocity of the gun, and that is the vg, because now it is recoiling itself and there will be some value of this velocity. Similarly, the bullet will have also a velocity, this will be the vb. Then what we say, we will apply the conservation of momentum. This is the initial and this is the final, and we will say that the sum of initial momentum should be equal to the sum of final momentum, or you can say sum of momentum before the incidence should be equal to the sum of momentum after the incidence. Now you can get here the result, mg ug plus mb ub should be equal to the mg vg plus this is the gun, this is the bullet, this is mb vb. And from here you can see the left hand side will be equal to 0, because ug and ub are 0. Then left hand side is equal to 0, and you will get mg vg is equal to the minus mb vb. This is an example. Similarly, we will discuss a topic that is the collision of two bodies. In that topic, we'll discuss how you can find the velocities of the bodies after the collision. How you can find the direction of the body after the collision. Next one, this is the example of the conservation of momentum, in which we say if there is a system, here is a system of bullet and gun, there is no external force acting on this system, then the conservation of momentum states that the momentum remains conserved, initial momentum is equal to the final momentum. Students, now let us talk about the impulse. It's a very simple topic, very small topic, impulse. Students, impulse can be defined as the very short duration effect of the force, in which some effect can be observed. I repeat again, impulse can be defined as the very short duration effect of the force, and in which you will observe a sufficient amount of effect. For example, hitting of a ball. In this incident, what happens? We apply a force using our bat for a very small time duration, and we get a very large effect. We can see the effect that the ball crosses the boundary. Similarly, you can see the effect of force when you insert a nail on the wall using the hammer. What happens? Just you apply a force for a short time duration and the nails enter inside the wall. Similarly, there are so many examples where we apply the force for a very short time duration and we get a sufficient amount of the effect. On one very interesting example is the kicking of a boxer. In the game of the boxing, you can see they apply the force for a very short amount of time and they get a sufficient amount of effect. Then that's why impulse is defined as the short time effect of the force. And the formula of impulse is, it is denoted by J. In so many books it is denoted by I also, and this is equal to the force multiplied by the small time duration. Unit is Newton seconds. I repeat again, the formula is force into small time duration is called the impulse, and its unit is Newton into second. Now students, one more thing you can observe from here, J is equal to, at the place of force what we can write, this is the dP by dt, and at the place of delta t you can also write dt. Okay, now dt will cancel out and what you will get, J is equal to dP, means impulse is equal to the change in momentum. Means you have one more definition, means impulse is equal to the change in momentum. By observing the change in momentum, you can calculate the impulse. Means you have two formula for calculating the impulse. One is the F into delta t, if a value of force and time, by multiplying these two values you can get the result. And third thing is, if you have a calculation of change in momentum, then by calculating the change in momentum, how? Pf minus Pi, final momentum minus initial momentum will be equal to the impulse. Then students, in our next class we will discuss about the collision of two bodies. Thank you for watching.